Module 7 B1 Test Prep. All right, let's get straight to it. I'm going to act as your senior mechanic today because passing this module, well, it's not just about memorizing facts. It's about really understanding the why behind the wrench. Section 1. Air Data Testing. So imagine you're pulling out the air data test set for a routine check. You really got to ask yourself, what is that adapter kit actually doing in your hands? You've got this seriously expensive piece of diagnostic gear, right? But how does it actually interface with the airframe? Well, the correct technical choice here is that it connects the tester to various sizes of air data sensors. Simple enough, but let's actually look at why this is absolutely crucial out on the line. Here's the practical reality of our job, apprentice. Aircraft sensors, they come in all sorts of crazy shapes and profiles depending on who built the thing. But our test boxes, those are standardized. So without that snug adapter fit bridging the gap, you're going to leak pressure. And listen, a pressure leak means you fail your test before it even starts. It'll feed you false data and send you on a complete wild goose chase. No one's got time for that. Okay, moving a bit deeper into the testing equipment itself. Think about what component inside the box is actually delivering that static pressure to the system. Any ideas? The answer you really need to lock in is a suction pump. Now, I know the word pressure might instinctively make you think of, blowing air into a system, but we actually have to reverse that kind of thinking here. This is a brilliant illustration of the physics of flight. Think about what the aircraft is actually doing. To simulate climbing to altitude, the surrounding air pressure has to drop, right? So we use a suction pump to pull a vacuum. We're literally drawing air out of the lines to verify that the instruments react correctly to thinner air. We're essentially simulating the sky while keeping the tires chalked right there on the tarmac. Section 2. Avionics Test Concepts. All right, picture this. You're staring at a massive rack of complex black boxes and you're trying to trace a fault. What are the two major ways you can actually test this highly sophisticated equipment? Well, in modern aircraft maintenance, you really have two primary avenues of attack. You're either relying on the aircraft's own built-in tests, what we call the bit, or you're bringing in external tests. The practical sequence on the hangar floor is pretty straightforward. First, you ask the computer to check itself. You run an interruptive byte, which is initiated right there from the aircraft systems while you're on the ground. Now, if that flags a deeper issue, or if you need some component-level troubleshooting that the onboard brain just can't handle, that's when you drag over the specialized external test equipment from the shop. It's a highly logical, step-by-step diagnostic process. Section 3. Nav and radio signals. Let's talk about the ILS. When you're verifying the instrument landing system, what exact signal types must your test set spit out to accurately simulate a runway approach for the aircraft's receivers? The crucial point to remember is that it absolutely must transmit both a VHF and a UHF signal to the aircraft antennas. You literally cannot test the system with just one band. And here is the why. This is the stuff that separates the true mechanics from the guys who just swap parts. The localizer, which gives you your horizontal left-to-right alignment with the runway, that runs on very high frequency, or VHF. But meanwhile, the glide slope for your vertical descent, that needs ultra-high frequency, UHF. So this means your test box has to simulate both simultaneously to actually prove the system can thread the needle to a safe touchdown. Make sense? Now, dialing in specifically on that glide slope test we just talked about, what exact frequency are we looking for on the carrier wave? This is a number you absolutely need to know by heart on the line, 330 megahertz. Burn that into your brain. I always tell my apprentices that 330 megahertz is the absolute sweet spot in the UHF band, and it's reserved specifically for the glide slope. Remember how we literally just discussed the need for UHF capability? Well, this is exactly why. If you aren't seeing numbers in this neighborhood, you aren't testing the glide slope. Simple as that. Finally, let's look out the hangar doors for a second at the VOR test beacon, the VHF omnidirectional range beacon sitting out there on the field. When we use it, how much power is it actually putting out into the airwaves?
The answer is actually surprisingly low. It is just 1 single watt.
And the reasoning behind this is purely practical. It's a localized test beacon meant only for the tarmac. So 1 watt gives us just enough juice to test the receiver locally on our specific aircraft. It prevents us from accidentally interfering with live, airborne traffic miles away that are actively relying on real navigation signals. Basically, it keeps our tests safe and totally contained. So as you walk off the hangar floor today and head back to your books, I want you to ask yourself something. Are you just memorizing a question bank to scrape together a passing grade? Or do you truly understand the physics and the logic of the machine you're about to sign your name to? Always dive deep into the why. Trust me, it makes all the difference when that plane is up in the air.